All right, guys, I know it's been a crazy week, and mainly we've been trying to focus on sea floor spreading and finish all that stuff. So if you would look at this diagram, all right, check this out. So this is different than the diagram that you did on the Google Docs yesterday, but things that you need to remember, things that you really need to be focusing on this week and committing to memory, is that the mid-ocean ridge. Okay, so this diagram's a little bit different. It's got all this extra wording and stuff that we haven't gotten into yet that we don't need to be worried about. But underneath the oceanic waters is the mid-ocean ridge. Right here, we see that it's splitting open. We've got the molten material here underneath that is coming up through. New seafloor is created at the mid-ocean ridge. Okay, now remember, our three main points of evidence that prove or support seafloor spreading is that the pillow lava, where we saw the video in class, we actually saw video footage of this molten material, this magma coming up through the ocean floor. That was one point of evidence. And then some of us got to do the activity in class. It was a simple activity where you put the dots on the paper that represented the drilling samples, that the newer rocks are found at the mid-ocean ridge. And as we get away from the mid-ocean ridge, those rocks got older. And then also this week we watched a video on the magnetic stripes and how the polarity on the ocean floor has switched over time, but how those stripes are the same on the right and the left on both sides of the mid-ocean ridge. Those stripes match up into a pattern. All right, so mid-ocean ridge, sea floor spreading takes place along the mid-ocean ridge. And what the heck does that mean? That means that new sea floor is being created alongside a mid-ocean ridge. Now, all important process right here. The ocean floor, the old crust, like a conveyor belt, gets pushed to the side. All right, so look at this crust where I'm highlighting right here. This oceanic crust, when it hits continental crust, because the oceanic crust is more dense, it is forced down, back down into the mantle. Okay, so guess what happens? What do we know about temperatures what do we know about temperatures down here in the mantle? Crazy hot. So what's going to happen when this crust gets forced back down? It's going to melt. Okay, so this process of subduction of the seafloor being forced back down into the mantle is the earth recycling itself. It's pretty crazy. New crust is made here, but the old crust has to go somewhere. So it's forced back down into the mantle. That process of being forced back down is called subduction. Okay?